Hi, welcome to this video on Envision Lesson 5.4. We are going to look at how to write, solve, and graph inequalities with addition and subtraction. And we are in your textbook, and we're going to start on page 274. So on to page 274, example 1 is already worked out for us. And this time, rather than us doing it, we're just going to read through the example and try to understand what they did. So in this problem, Raul is going on an airline, and on the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. So there's a weight limit. Okay, so think about that. How much can Raul's second bag weigh without going over the limit? So what am I trying to find here? That's always my first question. What do they want to know? So I want to know, how much can the second bag weigh? Well, in the picture, it's showing me that the first bag, this larger bag, weighs 38 pounds. So I want to figure out, well, what can the second pound weigh? Now, when they're talking about a weight limit, it's really saying what's the most that they can weigh. Like, the most weight they can be together is 50 pounds. They don't have to be exactly 50 pounds. That's what makes this an inequality and rather than an equation. Because if it was an equation, they would have to both be an exact amount. But in an inequality, we're saying that there is the most they can be. So this second bag he could just not even have a second bag. It could just be he only brings one, and it'd be 0. But what's the most it could be that he would still be able to take it on the airline? So what are we going to do with the weights of these two suitcases to get to the combined weight? So when we're combining the weight, well, combine means add. So we're going to add these two weights together, and that at most, those two weights can be 50 pounds. So let's look at what the book does. So in your textbook, underneath that picture on page 274, you're going to see they're taking you step by step with what you would do for this. So when we write inequalities, it's just like writing an equation. You're just like the equation. We had the total on one side, and then we had the expression on the other side. So on the left, you can see there's the weight of the first bag, and combine that with, that's add, the weight of the second bag, and they're using P for the weight of the second bag. Those two things together have to be less than or equal to 50. Well, and some of you are like, well, wait, it said most. So isn't that greater than? When it says at most, that means the most it can be is 50. So that means this has to be, so these things together have to be less than or equal to 50. So the biggest thing it can be is 50. That's why the alligator is eating the bigger number and it's eating the 50. Okay. So from there, we would solve it. And we're going to solve it a lot like we solve an equation. In order to isolate the second bag and get it by itself, the opposite of adding 38 is subtracting 38 from both sides. So we take away the same amount on both sides. That keeps the inequality in the same balance. And so we know that the second bag has to be less than or equal to 12. If it was 12 pounds, then together they would be exactly 50 pounds. But it can't be 12 and a half pounds because then it would be over 50. So, but could it be 11 pounds? Well, let's look at the graph. So another part of inequalities are, since there is not just one single solution to an inequality, there's really infinite solutions. We use a graph to represent that. So what they did is they did a closed circle at 12 because 12 is a solution here, because 12 plus 38 would be 50, which is part of the limit. But not only is 12 a solution, but everything that's less than 12, like 11. If I put 38 plus 11, is that less than 50? 38 plus 8 is also less than 50. So all of these things here on this blue line are all solutions to this inequality. Like the one bag could be, like right here we have this right here. So it could be like 9.6 pounds. 9.6 pounds, if I put it in the inequality, 38 plus 9.6, is that less than or equal to 50? Let me check. Well, let me add these together. That would be 47.6. Is that number less than or equal to 50? Yes. So anything in that area would be less than or equal to 50. But if his second bag weighed, say over here, 13.25 pounds, then if I put it in the inequality, I would have 38 plus 13.25. Is that less than or equal to 50? Well, 13, why do I pick these numbers? That's 51.25. Is that less than or equal to 50? Well, no, because this number is bigger than 50. So this is not true. So that's why this side here is not colored in blue, because it's not part of the solution. So that's how the graph works. Okay, so we've looked at a word problem, and you've seen how they wrote the inequality for it, and then how they solved and graphed it. So let's look at another example. If you're having trouble when you go to write these inequalities, here's a suggestion. Try writing an equation first, and then using the inequality symbol to represent which one's greater than or less than or equal to. So that's just a suggestion, and we'll see how that plays out. So here's a second example. I jumped right to page 275. We'll come back and do the try it. Here's page 275. This one is involving subtraction. The weather forecast predicted that the evening temperature could get as low as negative 12.5. So it's not saying it's going to hit exactly negative 12.5, but they're saying it could be as low as negative 12.5. Between afternoon and evening, the temperature dropped 7.5 degrees, which was consistent with the forecast. So what could the afternoon temperature T have been? Now, we talked about this. Whenever they just say letters in the middle of a sentence, that's the key. That must be the unknown. So T here is our variable, and T is going to represent the temperature in degrees. And so the temperature starts out to be a certain temperature and then drops 7.5. So if the temperature dropped, that's subtraction. So it's going to drop 7.5 degrees. And we don't know, over on the right is where we would normally, if we're writing an equation, we would have equals and we would have the end result. So after this, first this takes place and then it drops and then what happens at the end. But we don't know exactly what it would be. We just know that the lowest it could be is 12.5. That's the lowest result possible. But it could be negative 10 degrees or 0 degrees. There's lots of things it could be. But it's not going to be any it's not going to be any lower than negative 12.5. So I wrote this as an equation to start, but I need to put an inequality here because it doesn't equal exactly that. So the temperatures, the lowest it could be is over here. That means that's the smallest thing. So I'm going to put my inequality this way to say that these things over here could be bigger than negative 12.5 or equal negative 12.5. But negative 12.5 is the lowest number. So that's why the open mouth is going the other way. So now here I have my inequality. So let's look at the next slide here. And in your book, they have this inequality written, which we just wrote together, and then they solve it. So when they solve this inequality, they add they add 7.5 to both sides because that's the opposite of subtraction. You should notice in your book, whenever they add, they rewrite and they actually solve horizontally instead of vertically. But that's what they're doing. They're adding 7.5 to both sides, just like we would do. When they simplify the left, T is left over. And on the right, negative 12.5 plus 7.5 is negative 5. So that is the solution. T, the temperature, the original temperature, was something that was greater than or equal to negative 5. The next part after you've solved it in this way is you need to graph it. So it's already graphed for you in your book, but I want to show you how we would do that then. When I graph my solution to my inequality, I look at what we call the target number. So the target number here is -5. That's like the goal or the bullseye, essentially. I usually put that in the center of my number line because that's the most important number I need. And then I put things around it. So if this is where -5 is on the number line, then this would be -4, -3, -2, -1, and here would be 0. And then on the left, because negatives go this way, so -6, -7, -8, -9, this would be -10. And then I look at my solution here. -5. T is greater than or equal to, so -5 is a solution. It would be equal to -5. And let me make sure that works. So I'm going to check that. So RSS, I'm going to rewrite. And then substitute. I'm going to substitute in this possible solution here. And when I use a calculator, -5 minus 7.5 is -12.5. -12.5 is not greater than -12.5, but it is equal to, and equal to is allowed here. So that's why I did color in this circle. Now, this says T is greater than that. So that would mean greater than would go this way, to the right. All the things greater than -5 are to the right of -5. See how this symbol here matches the way the arrow is pointing? Okay, so that's the greater than. But I still should check it because sometimes I make mistakes. And sometimes things can get flipped around. So let me check and make sure. So I'm going to choose something over here as part of the solution and see if it works. So notice how when I have inequalities, I actually have to do the check twice. I'm going to pick a number that is on the right-hand side here, like -3, and I'm going to put it in the inequality. Since I have screen, I get to erase. You have to write it again. So I'm going to use -3 now. So if I rewrite the inequality, and then I use -3 in as a solution instead. -3 minus 7.5 is -10.5. This is where some of, I know for me in 7th grade, students get a little stuck because they're not really great at knowing which one's greater when they're negative. But remember, when numbers are negative, the bigger the number is, then the further it is away from 0 to the left of 0. So -10 is greater than -12. And because it's negative, they're kind of switched. So this is a correct solution. So I did graph it in the correct way. So that's good. So if you're struggling with that and you don't understand when it's negative, then just pick something that's really big out here, like 50. And if that works, then that would help too. All right, so we're going to look back then on page 274, and we're going to do the try it. What I would like you to do is, after I read over the example, you can pause and try it, and then come back and see what the answer is and see how you did. So Kyoko has completed 26 hours of community service. Her goal is to complete at least 90 hours this semester. Write and solve an inequality to show how many more hours, H, there's that letter, Kyoko needs to complete to meet her goal. Use the number line to graph the solutions. So before I let you go, what are we trying to find here? Well, we're trying to find H because it gives us an H. So H is the number of hours of community service she has to also complete. Now she's already completed 26, and she wants to complete a total of at least 90. So at least 90. What does that mean, at least 90? Would more than 90 be okay? Like if she did 100 hours, would that be okay? Would 80 hours be okay? So if it's saying at least 90, that means that 90 or more. Okay, so be keeping that in mind. Think about what's going to be bigger. So now that I said that, it's already kind of started for you here in the boxes. They have the H, so what would you add? And then in the circle is which inequality would you use? Would you use a greater than, less than, greater than or equal to, less than or equal to? Like which symbol would you use? So put that in the circle. And then try to solve and see what you get right here. And then we'll graph it together. So pause the video and try it on your own, and then you can come back and see what we did. So here is what I have. Since she has what she's already completed is 26, and she's going to do more hours, those combined together, those are what's being added, and then the 90 is on the other side. So she wants those things together to be greater than or equal to 90. Okay, so then once I have that as my inequality, then I started solving it, and they use, like I said, they always solve horizontally. We solve vertically. So I wrote underneath this 26. I'll write over here. So I had H plus 26 is greater than or equal to 90. So I would subtract 26 from both sides, and I would get H is greater than or equal to 64. Notice how this is only one step. I didn't have to divide by the coefficient because once I subtract, I have H by itself. So I've now solved this, and I have H is greater than or equal to 64. So she could volunteer for an additional 64 or more hours. So when I do that, they already have a number line for me, so I don't have to create it myself. I'm just going to look for where would I find my target number here of 64, and 64 is right here on this number line. Okay, and I have to ask myself, should this be an open circle or a closed circle? If it's equal to, that means that this could be a solution. So yes, it's shaded. So I would shade it in, but it's also equal to. Because everything that's a solution here will be shaded, including 64. So I should check that. 64, H plus 26 is greater than or equal to 90. So 64 plus 26, is that greater than or equal to 90? And that equals 90. So this is the part that gets people stuck, as they say, well, 90 is not greater than 90. I know, but it is equal to, and equal to is okay. So this does check here. Now, if I didn't have the equal to sign, then that would be a point to make, but still, it is equal to, so I'm allowed to shade it in. Now, which way will I graph it? Will I shade in things to the right of 64 or to the left of 64? Well, I can see in my symbol here, the greater than symbol, you see how the arrow is pointing to the right, just like this arrow here is. That means I should be going this way, but I'm going to check that because I want to make sure I'm right. Aren't the things over here greater than 64? Let's pick one. So I'm going to pick 75. Well, let's say she volunteered for 75 more hours. Then that would mean H plus 26 is greater than or equal to 90. So now I'm going to use 75 for H. 75 plus 26, is that greater than or equal to 90? Trying to move my face, and I make my face bigger. So 75 plus 26 is 101. Is 101 greater than or equal to 90? Well, another one people get stuck on. It's not equal to. No, I know. But is it greater than 90? Yes. So it has to has to either be greater than or equal to, and then it works. So yes, I've shaded it the right way. And just to drive home a point here, let me just put 60 in here. If I did 60, which is not shaded, 60 plus 26, would that be greater than or equal to 90? Well, 60 plus 26 is 86. Is 86 greater than 90? No. Is 86 equal to 90? No. It's not either one of those. So that's why it's not shaded, because it's not a solution. Only the things that are colored in are solutions. And not only that, but there are more answers. There's more answers that way. That's the arrows pointing that way, saying, look to the right for more answers that work. Yay. Okay, so that was the first try. We're going to do one more try it, and then we will be done. So the speed limit on a road drops down to 15 miles per hour around a curve. Mr. So-and-so slows down by 10 miles per hour as he drives around the curve. He never drives above the speed limit. Good for you. At what speed was this guy driving before the curve? So he was driving a certain speed, then he slows down, that decreases his speed by 10 miles per hour, and the end result is not going to be over 15 miles per hour. So pause the video now and write that inequality. We'll pause now. Okay, so the speed that he started off at will be x. I use x to represent the speed. He's in miles per hour. Then he decreases 10, so that's taking away 10 miles per hour. The end result is not going to be more than 15. So 15 is the most it could be. So that's why it's less than or equal to 15. So now that we wrote that inequality, now we are going to solve it and graph it. So to solve it, I would add 10 to both sides, just like it's an equation. And I would get x is less than or equal to 25. That means he had to start at only 25 miles per hour so that when he went down 10 miles per hour, he would be at 15. So now we're going to graph it, and there's no line here to graph it on. So in your book, though, there's this green line. So use the green line there under the try it, and you don't even have to make it darker. You can just use the green line, and I'm going to put my target number in the center, which is 25, okay, because that's where my solution is. And then I'm going to put some numbers around it. So let's see. So like 30, 35, 40. I'm going this way because I can count by fives. 20, we'll say 20 because my thank you's coming up. So we'll say 20. All right, good. 0. All right. Didn't let me do that. So now we're going to put our solution in. At 25, I ask myself, I say, self, is 25 a solution here? Should I shade it in? So I'm going to start with a circle and say, should I color it in? And since it's also equal to, then yes. So is it equal to? Yes. Then it's shaded. And I'm going to color it in because 25 works here. If I put 25, so if I have x minus 10 is less than or equal to 15, and I substitute 25 in here, 15 is not less than 15, but it is equal to 15. So that checks. Good. Now, where are my other solutions? So look at the inequality symbol. This says less than. Notice how this less than symbol is kind of like the same as the arrowhead over here. See how it's going in the same direction? It's going the opposite direction of this one. So it's pointing to the left. So I'm going to go to the left here and draw my arrow because there's more answers that way. Now, not really. Like in this problem, it would be a bound solution from between 0 and 25, but we don't need to worry about that right now, okay? I'm not going to make you write compound inequalities. This will do. We'll just say it's less than 25 and just go with that, okay? Now, just to check, I'm going to choose a number like 20. That's what I was allowed to write. And I'm going to try that in my inequality. So x keeps changing the color of the pen. X minus 10 is less than or equal to 15. So that's my inequality. Let me try 20. 20 minus 10, is that less than or equal to 15? 10 is less than 15. It's not equal to 15, but it's less than 15. And so yes, that's a solution. So I did graph the right way. And I should also think about this logically, just in case I wrote the inequality the wrong way. If Mr. G was traveling 40 miles an hour to start, let me try a different number on my number line. Let's say he was traveling 40 miles an hour and he slowed down 10 miles an hour. That would put him at 30 miles per hour when he hit that curve. Would that be over the speed limit? Yeah, so 40 is not a solution. But let's say he was going 22 miles per hour. So if he's going 22 miles per hour, like that's over here on my graph, going 22 miles per hour, and he slowed down by 10, well, that would put him at 12 miles per hour. If he was going 12 miles per hour, would that be under the speed limit? Yes. So my solution is correct. It matches the story, it matches my inequality that I wrote, and it matches the story logically. So there you go. So from there, there may be some practice that your teacher's providing for you, but that's your lesson on writing inequalities with addition and subtraction. Thanks.